Hi, this is our presentation for AccentAI. I'm Grant, and Clay will also be presenting some of the slides. So the problem we're trying to address is the accent barrier in speech recognition technology. So systems such as Alexa, when people with accents try and use them, such as second language speakers of English, the results can be pretty bad. So we have some examples of how Alexa has misunderstood some speakers, and it causes some frustration. These models are built using large language models for speech recognition, and these are trained on vast amounts of text data as well as audio data, which enables them to understand and generate human-like language. These have revolutionized automatic speech recognition by improving accuracy and understanding of diverse language patterns. But since these systems are trained mostly with native speakers of a standard accent of English, they perform less well on uh, accented speech data. So we want to use these models and leverage them to better understand accented English speakers.
Some of the data sets we used in our approach included the Common Accent dataset, which has over 10,000 training audio samples of accented speakers of English and 451 testing audio samples. We also used the Speech Accent Archive from Kaggle, which has 2,140 records of audio. An example below shows the data and how it's formatted. And in our approach, we wanted to first run just a baseline of the OpenAI Whisper Small model, which is a pretty standard model for automatic speech recognition and transcription. We ran it on the Common Accent and the Speech Accent Archive data sets, and it served as a baseline model for what we want to improve on with our fine tuning. And then after we fine tuned our model with the Common Accent data set and using feature extraction and tokenization, we wanted to then retrain the model and run it again on that data set to see if we could improve the performance of the model on accented English. To evaluate this, we used the word error rate, which an example below will show how we can identify errors in a transcribed sentence. Some of our preliminary results from our baseline showed the small model had the best average word error rate, which is again why we went to go with this for fine tuning in our approach. And then when we ran the small model on the common accent data set, initially we received an average word error rate of 46.5, which was relatively large. After fine tuning using the tokenization and feature extraction, we were able to get this down to at lowest 20.5, which is a significant improvement from the baseline. And here is a graph showing the training versus validation cost. So it shows that we do actually still see a high validation loss that actually increases as the steps went on.
So the model achieved significantly improved performance on the validation data compared to the pre-trained model. The word error rate was almost or more than half, but the model might have room for improvement. As previously mentioned, the large differences and the increasing differences between the training and validation loss suggests that the model is overfitting to the training data. And another problem is that the model can sometimes output nonsense words. So these are problems that moving forward we need to address. Um, but in conclusion, the model in its current state seems to be a step towards improving the usefulness of speech recognition tools for speakers of English with non-standard accents. But more work can be done to increase the model performance. So, for example, the um, model's ability to generalize and its overfitting, some techniques that we want to apply to address that are dropout normalization and also different values for other hyperparameters.